core network. So remember the big costs incurred on the base station in the form of the physical towers, the rent of the towers, the rent of the equipment, the maintenance of the equipment, the power requirement of these equipment, the security requirement of these equipment. So remember the base station is one of the major costs of any network. Same is true with the fifth generation of the network. So in fifth generation of the network, we have an issue of densification, which means that we required a large number of base stations for 5G network compared to 4G and 3G. Why? Because we are using a high frequency uh, in the range of gigahertz, and gigahertz connectivity is not possible for larger distance because of the losses and the penetration issue of higher frequency. This is the main problem. Remember, we have to identify the problem before proceeding towards the solution. And our problem is the densification, means we need more base station towers. And if we deploy the similar type of towers as we have in 4G and 5G, we cannot make money out of the network. This is the main problem of the mobile company operator or cellular operator. So what they did is to decouple the costly component of the base station tower, that is the baseband unit, as seen with the blue line, blue box. Blue box is called the baseband unit and is responsible for digitizing the radio signals for a number of reasons. It is also responsible for various radio resources and load balancing. So cloud RAN or centralized RAN is the attempt to decouple the baseband unit from the base station. And now the base station is much more simpler compared to the base station we have for 3G and 5G. If you have a chance, go to the YouTube or Google it, the base station for 5G. Let me find out the base stations for 5G. So this is the 5G towers, which is much smaller than the traditional antenna towers we have. Let us see different pictures of these antennas, 5G towers, MIMO tower rather, 5G, MIMO tower, MIMO antenna, MIMO antenna. MIMO antennas is relatively smaller in size. This is the MIMO antenna. Remember, it consists of arrays. If you look at this is 10 by 10 array antenna, and each single spot is called the space. And each single dot is showing you as the antenna. Imagine now you are having 100 different antennas serving you through beamforming. These two technology are a very crucial part of the 5G communication. And this thing is not very big. It's smaller than the street light. So and it is mounted on a simple poles. Simple poles. And another picture of the MIMO antenna. Most antennas are relatively smaller in size, but it has much more capabilities. So far what we have discussed is that now with MIMO antennas and beamforming and decoupling of baseband unit, now the cost of the base station for 5G is reduced tremendously. Now we can have large number of simplified base station compared to the base station of 3G and 4G communication. Remember that the technology has been introduced so far is called massive MIMO in the form of the antenna and beamforming. So you have much more energy per unit areas compared to 4G and 5G, and it supports a large number of services, which is not possible in case of 4G communication. So this is the beauty of CRAN architecture. Let us move to our slides. We already discussed this thing, how it's works. This is an important question that how the pool of baseband unit works. So just like how many of you have been using the Google Drive? Google Drive is also a cloud network primarily designed for storage purpose. I myself prefer to use heavy files on my personal computer to the Google Drive, but it may have security issue, but it's not been informed so far. Just like a Google Drive we have used for storage, we can have a cloud radio access network for baseband units that perform different operations, including radio resource management, load balancing, traffic management, and so on. So the stack of BBU pool at the central office also allowed load balancing spectrum across the number of RF radio resource units. The load balancing feature is crucial for fulfilling 5G expectations. Remember, 5G use a very costly spectrum chunk, that is the gigahertz spectrum, and the spectrum is very costly. And if the companies effectively use these radio resources, they can save a lot of money. And the way to save the money is to centralize the use of baseband units. They have number of advantages of centralized baseband units. It can save a lot of cost of the base station towers, but also reduce the cost of unutilized spectrum by different net part of the networks. So this is the key part, centralizing the base. Now we do not have a single baseband unit linked with the base station. Rather, it moved from each single tower to a centralized place. And if we have lot of baseband units in a single infrastructure, we can manage it more effectively. Different network equipment such as router, physical infrastructure, cooling, electricity can be saved. So for individual tower, we do not require to take care of the baseband unit. Rather, we pool all the different baseband unit in a single location. It not maybe physically in the same place. As you know that it's a cloud centric, you do not see the location of baseband unit. Rather, it is being in some another part of the world. This is the important slide for those who understand the cost advantage of cloud rent. Remember, when we reduce the cost on each tower, then we may able to increase the number of towers in a given network. So this is what the initial question to address. With the cloud rent, we can save about one third of the capital expenditure. For example, if we need to develop a network for 30 million US dollar for a medium-sized city, instead of 30 million, we only have to spend 10 million US dollar to support the network. So in this way, 20 million dollar of the cellular operator can be saved by using this new architecture, that is cloud RAN. On the other hand, we can save one second of the total cost on civil work, planning, and network equipment and installations. By installing CRAN, resources can be shared potentially less expensive than the remote site with radio antennas installed at the base station together. Yet it is also possible that in some far-flung areas where it is not practically possible to have a pool of baseband unit, we still have towers which we have both the radio resources as well as the baseband unit. So still it is possible. Another advantage of CRAN is the evolving on sustainability and green energy. Remember, if we have more base station in each corner with the baseband infrastructure that is require power and cooling and different other uh, activities that is not good for the environment. So by simpler base station, we can it will be a green, sustainable and environmentally friendly. Front Hall and Ray CRAN architecture contribute to achieve the goal by removing BBU consumption out of the cell tower and centralize one put. One other advantage of cooling of the baseband unit is that we can reduce the power requirement of each cell just for the use of radio resource unit. CPRI, CRAN architecture deployed by Telecom using CPRI. CPRI stands for, it is a protocol used for interfacing between the different base station to the CRAN, and it is proprietary and it is expensive. We may have another options. We can avoid CPRI because CPRI required investment. We can use unused fiber optics to connect our base stations to remote baseband units. And these baseband units can be connected with unused fiber optical in which we call dark fiber, because a large number of fiber in our city even is not being used for any reason. A fiber which has not been used for any application, it has been idle for many years, is termed as dark fiber. Die fiber unit, these by mobile operator which light up with own practical equipment. Some more discussion about CPRI is given over here. Before proceeding toward the last section of the today's webinar, let me wrap up the previous discussion. In previous discussion, we have seen two important components. One is the introduction of 5G, classical radio access network or a traditional radio access network, CRAN, which we have discussed a little earlier. So remember, the 5G will bring a lot of new advancement, including intelligence application, IoT, healthcare, and so on, which is not easy with the infrastructure provided by 4G. Remember what do you mean by the infrastructure? Infrastructure includes the railroads, and these things are considered as infrastructure. Today's infrastructure is much more advanced. We need a very strong, resilient radio communication network, not only for our communication needs, including broadband needs, but also for commercial needs, including industrial, healthcare, and different logistic needs. So 5G is nothing but a strong, resilient infrastructure that is capable of providing future services, which is not possible without the new generation network. Remember, we have talked about smart vehicles, autonomous vehicles, Internet of Things, uh, car polluting, smart metering, smart agriculture, healthcare, massive IoT application, intensive IoT application. These all new technologies and services cannot be implemented without a strong, new, much more advanced 5G network. In simple words, 5G network is much more powerful, innovative. It have much more availability as compared to 4G and 3G. The last component of today's network is called software defined network and its role for 5G communication. Uh, this particular session, the last section, consists of software defined networking basic and open flow, which is the interface between the uh, data plane and uh, another plane. Basic, we will see software defined architecture can be divided into two discussions. One is IATF, forwarding and control element. Another one is decoupling of control plane. The difference between the SDN and the classical networking technique is that the data plane and networking plane, control plane now is decoupled. Just like we decoupled baseband unit from the tower, we are decoupling the component of control unit from the data plane. Let's look at the different definitions of software defined network. Let me read it for you so we will discuss it thoroughly. The software defined network architecture decouples the network control and forwarding function, enabling the network control to become directly programmable underlying infrastructure to abstract application and network services. This is the definition provided by Open Network Foundation. Likewise, we have another definition from ACM. Software defined refactor the relationship between network UIs and that control and the software that control them. Opening the interface to program the network enable more flexibility and predictable network control and make it easier to extend the network with new functionalities. Before I proceed, let me uh, give some light on the SDN versus CRAN. Both have the introduction of decoupling. Remember, we decouple the radio resource unit with the baseband unit because the baseband unit require much more power and computing equipment. So, say in likewise, what we have the decoupled the radio resources and the baseband unit. Now we are decoupling the control part of the network with the data plane, which is responsible for forwarding. Now, this is one of the important diagram of SDN. You remember, in the network architecture, we have a host and the core network. Just like I am giving you a lecture from my mobile phone. My mobile phone is a host that is connected from the radio access network to the core of the network. This part actually belongs to the core of the network. The first interface of the core network is called the network application, and at the bottom we have the data forwarding plane. In between we have a controller. So let's look at the basic definitions over here. Software defined network networking architecture, data and control plane decoupled from each other. Control is the brain part and data is the forwarding or the action part of the network, which is responsible for forwarding. Data plane is the forwarding device managed as the controlled remotely by a controller. Well-defined programming interface between control and data plane. Likewise, well-defined programming interface between control and data plane is called the interfaces. We will also discuss this open interface. Applications running on control manage underlying data plane. So when we look at the diagram, the diagram consists of network application followed by northbound API, southbound API, and finally a network infrastructure which is responsible for the core routing operations as shown in the routers inside a cloud. Data plane. Data plane consists of interconnected forward device like forwarding planes. Forwarding device, the hardware. It may be hardware or software. They're responsible for forwarding. Flow, sequence the packet between the source and destination. Flow rules are the instruction act on the incoming the packets, and flow table, which consists the switches and rules to handle the flow. It's just like a role of civil aviation authority for the aviation. You know that civil aviation authority means is for controlling the planes from one country or one city to another country. They have the routing tables, they have the addresses, they have different rules. They can deny any passenger from entering the airport. Likewise, in SDN, there are rules which is called flow rules, and these rules are written in the form of tables. Control plane controls the plane logically centralized. The control is called network operating system. Southbound instruction to send program, control, and data plane. Remember, control plane is the brain of the network router, and which is responsible for taking decisions. Classically, routers have control plane and data plane in a single place, and it is very difficult to link these control plane with each other. Now we SDN we decouple or displace the control plane from the router to some remote place. So it becomes centralized just like a pool of baseband units. Northbound interface control to develop network control and management application. There are two APIs. One is for the upper part is called open northbound, and the below it is called the southbound. Management plane function include routing, control of the infrastructure. SDN application. Remember, if you look at the Civil Aviation Authority, it can do number of applications, including the managing the traffic, air traffic. Likewise, SDN is responsible for handling traffic, provide the quality of service, maintaining the power consumption. On the other hand, wireless networks support and it supports handover, load balancing, heterogeneous network of use of this. These are some applications of the software-defined network. Even firewall, storage, networking, fault detection is fall under the umbrella of SDN application. So far, we have discussed that software-defined networking means uh, the forwarding part is separate from the brain of the switch. This brain of the switch is called the control plane. Now, control plane is not linked with the individual router, rather it is centralized, and it has been pooled for various router or switch of the network. Whenever we centralize any equipment, we may have a lot of control over it, as well as we can have reduce the cost of the network. We have heard about network function virtualization. Remember, have you seen any router switches in your office? Yes, most of you work in banks, in companies, at the IT department. You have seen a large infrastructure consists of the switches. At Hamdard University, we have IT department, and in the IT department, there are separate place dedicated for the switches and router. It is a very big room with AC running 24/7. it required physical security, it required continuous power, it requires continuous cooling. So whenever we have a equipment-based networks which involve hardware, a lot of hardware, that it incurs not only the initial capital expenditure, but also operational expenditure. So instead of having a hardware, we are using software equipments that is called network. That is term under the concept of network functional virtualization. For example, if I ask you to please install a firewall at your office, you will go to the market to buy a hardware that have the firewall capabilities. But in case of network function virtualization, these firewalls, routers, switches now can be implemented through a software in a very small, you can say the FPGA, Xilinx, similar to the FPGAs. So now the equipment can be implemented with the software logic. You don't have to buy the whole equipment. The advantage is that you can use the same hardware for multiple functionalities if you have a network functional virtualization concept. So if you look at the diagram, the network equipments now implement using network functional virtualization, and the core capabilities of the network is now implement using software defined networking, in which we decouple the control plane with the data plane. So we're making the system more simpler, and the involvement of software activity is much more higher for 5G networks. So we can say that in the future, we will have a much more simpler network in terms of hardware, but it has much more stronger capabilities using the concept like network function virtualization, software defined networks, CRAN or cloud radio access network. Let me read the definition from here, the slide. SDN, flexible forwarding, is sharing of traffic in a physical or virtual network environment. Likewise, flexible placement of virtual network function across network and cloud. And the complement is also possible that we can both in the network. So in this slide, we have discussed that our future network is getting much more software oriented. Whether we buy routers, costly switches and routers, firewalls, we can have network function virtualization or still there, Adil?
Yes, sir, we hear you. Meeting will be end after 2 minutes. So the fourth session and last session of this activity will be shared with you, and this will be the
More
count as break of 5 minutes.
5 मिनट 10 मिनट कर लो यार, 5 मिनट आने जाने में निकल जाते हैं,
Okay, sir.
चार
We
दस
can.
मिनट के लिए.
Okay, sir.
We
We
will
start
start
the
at
session at 4:10.
अभी कितना टाइम हो रहा है?
Sir, we have only 2 minutes
फोर अभी
left
हो
to
क्या रहा है,
discuss.
टाइम क्या हो रहा है? Okay, we will back in 4:10. Okay, अस्सलाम वालेकुम.
Okay, sir. Okay.